In this video, we're going to derive the quadratic formula so that we can see where it comes from and how it is that we end up with that formula as a way to solve this type of equation. So the quadratic formula starts off with a quadratic equation that's in standard form, like this one here. That means that there's a 0 on one side of the equal sign. So we've kept things very general here just by using a, b, and c instead of actual numbers, so that we can actually come out with the precise quadratic formula. So what we're going to do here is we're going to follow a process called completing the square in order to solve this equation. And the first step there is going to be to factor out this number a that's in front. So that leaves us with an x squared here. But then to get our coefficient on the x term, I would have to do b over a. I don't know, any particular values here, so I'm not even sure that a goes into b evenly, but we can divide a out by doing b divided by a. And similarly, I would get a c divided by a there, but I'm actually going to stop right here and end my parentheses, and then I'm just going to keep that plus c on the outside by itself. And in fact, we'll go ahead and just subtract c from both sides here. So part of the process of completing the square is that we want to choose that constant term that we can add there in order to make it a perfect square. And so the constant term that we began with, that c, we're just going to basically kind of subtract it off to kind of get it out of the way for now. And so I'm going to leave myself some room here because I'm going to add something in to make this a perfect square. And so the kind of the trick with completing the square is that the constant term that we want to add is going to be half of this middle coefficient and then squared. So we want to take half of b over a and then square it, and that's what we're going to add here. So let's do a little bit of work off on the side here. So half of means 1/2 times b over a, and so just multiplying straight across the top and straight across the bottom, we get b over 2a. And then if we square that, we get b squared over 4a squared. So that's what we want to add inside here in order to make this a perfect square. Now, I can't just add that in without affecting the entire equation. So I need to keep this equation balanced, and because I just added this on the left side, I need to also add it on the right side of the equal sign. But I have to be a little more careful than that here because I didn't just add b squared over 4a squared. I added it inside this set of parentheses with that multiple of a outside. So really on the left side of the equal sign, if I were to distribute this a back in here, I would get my ax squared plus bx. Then this a times b squared over 4a squared, one of those a's would cancel, and I get b squared over 4a. That's effectively what I just added on the left side. And so to keep my equation balanced, I have to add that same thing over there on the right side. So the whole purpose of doing that addition, though, is to make this expression here that's in the parentheses into a perfect square. So we have now accomplished that. And the way that this factors is x plus something squared. And that number that we put in there, or that expression in this case, is what we got up here with the 1/2 times b over a, that b over 2a. That's what goes in there. So by adding that term in the way that we did, we made it so that we could factor that expression as a perfect square. And just to kind of confirm that, let me do this work on the side here. X plus b over 2a squared means x plus b over 2a times x plus b over 2a. And then if I go ahead and multiply this out, I get x squared plus x times b over 2a, or b over 2a times x, plus b over 2a times x again, plus b squared over 4a squared if I multiply straight across the top, straight across the bottom. I have some like terms right here in the middle. They both have x to the first power. So I'd be combining b over 2a plus b over 2a. Those have the same denominator already. So I'd add the numerators. B plus b would make 2b over 2a. And then we can simplify 2b over 2a. That would simplify down to just b over a. The 2's would cancel. And so when we multiply it out, we do see that, in fact, we get what we started with in the set of parentheses up there. So we factored it back down at this point. And so now we want to begin the process of getting x by itself. So we're going to divide both sides by a, because that's the multiple out in front of that set of parentheses there. Equivalently, we can say that we're multiplying both sides by 1 over a. That would probably make it a little bit easier to distribute there on the right side, if we think of it that way. So the a's cancel here on the left, and I just have this x plus b over 2a squared. And if I distribute here on the right side, I get negative c over a plus b squared over 4a squared. Is straight across the top, straight across the bottom. So let's do a little bit of work on the right side here. We'll get a common denominator with these two fractions so that we can make them into one fraction. So my common denominator is going to be 4a squared, which my second term already has. So my first term I need to multiply on the top and bottom by 4a to make it so that there's a 4a squared on the bottom. That gives us a negative c times 4a, or 4ac, over 4a squared, plus b squared over 4a squared. And so combining that into one fraction gives us a negative 4ac plus b squared. We just add the numerators. Or if I switch those terms around, get b squared minus 4ac, which is probably starting to look a little familiar then from the quadratic formula. And all of that's over 4a squared. So to continue getting x by itself, on the left side we have a quantity that is squared. So to undo that, we would take a square root of both sides. Anytime we take a square root of both sides, we have to use a plus or minus. And so that would leave me on the left side with just the x plus b over 2a. And on the right side, I get this plus or minus. And I'm going to split this up on the top and bottom separately. Square root of b squared minus 4ac. And then on the bottom, the square root of 4 is 2, and the square root of a squared would be a. So I don't have a radical on the denominator anymore. And then lastly, to get x by itself, we would subtract b over 2a from both sides. And to get this to be in the form that we are used to seeing for the quadratic formula, we would put that negative b over 2a in front of the plus or minus. And because they have the same denominator already, 2a, we can just write that all over or as one fraction. And there we have x by itself, and that yields what we are hopefully familiar with as the quadratic formula.